of trig functions. So I don't know if you had gotten a chance to watch the notes or not, but I'm just going to do a review either way. So all 6 trig functions, we have like a derivative, and they're just like just things that you have to know. So like we're getting out of the just being able to find a derivative by ourselves. Now, you can solve and figure out what the derivative would be, but it's a whole thing to try to figure it out. So normally you just have to memorize them. So the derivative of sine of x is cosine of x. The derivative of cosine of x is minus sine of x. The derivative of tangent of x is secant squared of x. The derivative of cosecant of x is minus cosecant of x cotangent of x. The derivative of secant of x is secant of x tangent of x. And then the derivative of cotangent is negative cosecant squared of x. So those are our 6 trig derivatives. Another thing that's going to often come in handy working with this stuff, more so as we're simplifying a problem, not so much with the initial finding of a derivative, but the Pythagorean identities, so like sine squared x plus cosine squared x is equal to 1. 1 plus cotangent squared of x is equal to cosecant squared of x. And then tangent squared of x plus 1 is equal to secant squared of x. Now, other trig identities probably will be useful as well, but a lot of times these are the ones that people forget, so I like to review those ones. But if there's other ones as we're going that we need to review, obviously we'll stop and review them. So let's see where we're at. Find dy dx for the given problems. So number 2, y equals 2 sine of x minus tangent of x. So with this, if there's a number like by itself, like not, with an x or something in front of our trig function, that number is going to stay with our derivative. So like it doesn't go away. So this would be y prime is equal to 2. The derivative of sine of x is cosine of x. So this would be 2 cosine of x. And then the derivative of tangent is secant squared, so minus secant squared of x. And that's the answer for that one. For y equals x secant of x. So with this one, we have 2 things being multiplied that like both obviously have a variable in them. So I'm going to have to use the product rule on this one. So this is going to be x times the derivative of secant of x, which is secant of x tangent of x, plus the derivative of x is just 1 times secant of x. I'm okay if you leave it here. If you take it one step farther and factor out the secant of x and then have x tangent of x plus 1, like that's also fine. The book leaves it here also though, but just so that you can see either way would be fine. 6, y equals 3x plus x tangent of x. So obviously this first part we can just straight up take the derivative and get 3 plus over here we have to do the same thing we did in this one up top. So x times the derivative of tangent of x, which is secant squared of x, plus the derivative of x is just 1 times tangent of x. And on that one, I would obviously just leave it like that. Um, 10. Y equals the cosine of x over 1 plus the sine of x. So obviously we're going to have to use the quotient rule on this one. So that is the derivative of the top, which would be minus sine of x, times the bottom, 1 plus sine of x, minus the top, cosine of x, times the derivative of the bottom. Derivative of 1 is just 0. Sine of x is cosine of x. And then all over 1 plus sine of x squared. I think I've mentioned this before, but I would leave the bottom this way. I wouldn't like multiply it through until the end if you need to do it, because a lot of times it works out nicely where it cancels. So to simplify it, I'm going to have negative sine of x minus sine squared of x minus cosine squared of x over 1 plus sine of x squared. So this is where our identities come in. Obviously, these are both negative, so I can factor out the negative of that, which is going to give us sine squared plus cosine squared. Or you could just recognize that that's going to end up being -1 since they're both negative and the identity is this, then it would have to just be a -1. But I'll write it this way for now. So negative sine of x minus 1 times sine squared plus cosine squared over 1 plus sine of x squared. So that right there is going to 1. So I'm just going to cross it out and write it that way. So now I've got negative sine of x minus 1. I can take a negative out of that one as well. So then I would have on top, and I'm going to reorder it just because, negative and then 1 plus sine of x over 1 plus sine of x squared. So now I can take and I can cross out this 1 plus sine of x on top, and then I can get rid of the squared piece on the bottom, so that I'm just left with -1 over 1 plus sine of x. So obviously kind of a lot to them. If you can shortcut things, like once you're down into just like the algebra, the trig of it, you can obviously do that, but just trying to show as much as I can right now. A weight hanging from a spring. Throw back to physics again. Actually, did we do springs yet? I don't think we did, actually. No. Well, preview for physics then. Bob's up and down with a position function, s equals f of t in meters per second, or well, s is in meters, t is in seconds. What are its velocity and acceleration at time t? So if they give me position, how do I find the velocity and acceleration?
With a formula of some kind.
Huh?
Is it like a formula of some kind?
Well, if you're given just like a position function, we would take the derivative to find velocity, and then the derivative again to find acceleration. That's where it gets confusing between physics and calculus, because yes, you would need a formula to do it in physics, but in here you can just take the derivative of it. So the velocity would be 7 Now, the derivative of cosine is minus sine, so it's going to be negative 7 sine of t. Then acceleration. The derivative of sine is cosine, so that would mean it's negative 7 cosine of t. So the kind of like big difference or whatever between obviously like regular and trig is that there's pretty much at no point is it just going to straight up cancel, unfortunately. Because obviously, especially with like sine and cosine, which is what you typically end up with, just keeps bouncing back and forth between the two functions. So same kind of deal here with the next problem, just having us do a little bit more with it. It says a body is moving in simple harmonic motion with position function s equals f of t. Find the body's speed or velocity, speed, and acceleration at time t. And then for part B, we're actually given like a t value to plug in for it and solve. So 16, we've got s equals the cosine of t minus 3 sine of t. I'm going to, I guess, like do all the a things going down, and then I'll do the at t equals pi over 4 over here after we find them, just so that way we can just have everything together. So velocity is first. So what would the derivative of this function be?
Negative sine t minus 3 cosine t.
Yep. So then I'll go ahead and evaluate for pi over 4 here so that we can find it. So v of pi over 4 is minus the sine of pi over 4 minus 3 cosine of pi over 4. Do you remember what the sine of pi over 4 is?
Root 2 over 2.
Yep. So since it's negative, sine will be negative root 2 over 2. And then what about of cosine of pi over 4?
Same.
Yep. And then we've got the negative 3 there. So minus 3 root 2 over 2. So that ends up just giving us, let's see, negative 4 root 2 over 2, which would just be negative 2 root 2 then for velocity. Now speed is just the absolute value of velocity. So for the function here, I usually will just do this, like write it that way, or you can say the absolute value of negative sine of t minus 3 cosine of t. So I don't obviously usually redo all of the math. I usually just take whatever value that I got over here and I just do the absolute value of negative 2 root 2 and then just go to 2 root 2 that way. And then lastly, acceleration. A of t. So, what's the derivative of the velocity function?
When you like change an absolute value, wait.
So we're just going back to the velocity function. This
Oh, okay.
the speed is purely just to give us a value, a number value usually. So then we've got a of pi over 4 is negative cosine of pi over 4 plus 3 sine of pi over 4. So I've got negative root 2 over 2 plus 3 root 2 over 2, which is obviously just 2 root 2 over 2, or root 2. So this is the section where if you've forgotten your unit circle, you'll probably want to do a little refresher on that. Just because obviously it gets into a lot more with this one. The next one's kind of a continuation, still simple harmonic motion. They want us to find the jerk at time t, so remember that's where we would be finding then the derivative of acceleration to give us that. So we have to start out if they're giving us position, so that means we're going to have to work our way all the way down. So s is equal to 1 plus 2 cosine of t is the initial problem. So the velocity function then would be what?
-2 sine t.
Yep. So then acceleration would be
-2 cosine t.
yep. And then jerk, derivative of that.
2 sine t.
Yep. All right. Find the equation for the lines that are tangent and normal to the graph of y equals secant of x at x equals pi over 4. So these work the same way that they did with like the other ones. We're finding the tangent and the normal. We still have to find the slope first and then rewrite it as an equation of a line. It's just a little bit more involved now. So 22, y equals secant of x at x equals pi over 4. So first thing I have to do, well, to find the slope, I obviously need the derivative of this. So y prime is equal to derivative of secant of x, tangent of x. And then obviously evaluated at pi over 4. So secant of pi over 4, tangent of pi over 4. Let's see, secant of pi over 4 would be 1 over the cosine of pi over 4, which would be 2 over root 2, so that would just be root 2, I think. And then the tangent of pi over 4 is 1, right? I think. I believe. Let me check. I think I have a unit circle over here somewhere. Let's see. Cosine of pi over 4 is root 2 over 2, so flip that. 2 over root 2, which would be, yeah. And then, yep, tangent's 1. All right, so that's our slope. To find the y value of this equation, though, I know x, I need to plug in pi over 4. So the secant of pi over 4 is just root 2. So the point that I'm using is pi over 4 and root 2 to write my equation. So then my tangent line y minus root 2 is equal to root 2 times x minus pi over 4. A lot of times we end up just leaving this way, just because these don't come out to be like nice even numbers, but if you want to move it over or at least write it like y equals root 2 times x minus pi over 4 and then plus root 2, you're welcome to do that if you want to, but a lot of times I just leave it here. The book does take it all the way to slope-intercept form, but 99 times out of 100 probably we're not actually graphing this, so we don't really need to worry about that. The only way it could be an issue is if they asked you to write the equation of the tangent line like on the exam and they gave it to you as multiple choice in y-intercept form. But I mean, I trust that you could move that over and figure out what it is. And the book puts their answers in decimal form, and I would not most of the time use decimals. I would just leave it. So now the normal, what would the normal slope be? So this one was root 2. So what would the slope of this one be?
Negative root 2 over 2.
Yep. Negative root 2 over 2. So then equation y minus root 2 is equal to negative root 2 over 2 times x minus pi over 4. And again, you could leave it here, you could move it over, I don't care. All right, the next ones are a form of a proof, but not in the sense of like the proofs that you did in geometry where like every time you do something you have to explain why you did it. These are more just like showing how or why like the derivative of say like tangent of x is equal to secant squared of x. So we're basically going to use the information that we know that the derivative of sine is cosine, the derivative of cosine is negative sine, to find or to confirm these ones. So we'll do 2 of them, and then I think there's 2 of them that you'll do in your like homework problems. So 26. Prove the following. The first one, d dx of cotangent of x is equal to minus cosecant squared of x. So I'm trying to show with what I know that cotangent is equal to that, aside from me just straight up knowing it. The only real benefit to you being able to do this is that if you ever forget what the derivatives of the other 4 trig functions aside from sine and cosine, you can use this to find them. So what I usually do with one like this is I would rewrite this as like d dx of cotangent can be written as cosine x over sine of x. So I usually like to start there, like rewriting them in terms of whatever they are, or if it was like the derivative of like secant, I would write it as 1 over cosine and then basically proceed like a quotient rule problem. So we have the derivative of the top, so minus sine of x times the bottom sine of x minus the top cosine of x times the derivative of the bottom, which is cosine of x, all over sine squared of x, or sine of x squared, doesn't matter. So then on top I get, I'm going to go ahead and take out the negative, and then sine squared x plus cosine squared x over sine squared x. And then sine squared plus cosine squared, this is again where your identities come in handy. Well, that's just equal to 1. So then negative 1 over sine squared would be negative cosecant squared of x. So this is almost like a variation of like when we were verifying identities last year, just with derivatives instead. If we were going to do the second one that is in this problem, d dx of cosecant squared of x is equal to minus cosecant of x, cotangent of x. I don't know why I stuck a squared right there. I think I was looking up there. It's just the derivative of cosecant of x. You don't know how to take the derivative of that squared yet. All right, so how can I rewrite cosecant?
1 over sine x.
Yep. So 1 over sine of x. And then I just proceed as if it's a quotient rule. So the derivative of the top is 0. So I usually just put 0 minus the top times the derivative, or yeah, the top times the derivative of the bottom. So that would be cosine of x over sine squared of x. So I basically have negative cosine of x over sine squared of x. So what I tend to do is I'm going to actually break this up because I know what I'm trying to get to, right? So I would almost rewrite this as negative 1 over sine of x times cosine of x over sine of x, because I can see, okay, well, I need to get to cosecant and I need to get to cotangent. And so negative 1 over sine of x is negative cosecant of x. And then cosine over sine is cotangent. And then there's that one.
Where did you get the negative 1?
From the minus cosine. Right here. And then I'm just multiplying. I basically just broke up the bottom into sine times sine instead of having it written as sine squared. Now, I probably could have, without writing it that way, I could have gotten to the same end result, obviously. I just think it's easier to see if it's split up. Oh, wait. It's only 24. Wait, we got out 29? Okay. I'm going to do this last problem, and then that's all that's in this section, so then you wouldn't need to stay for 7th. So, I mean, if you want to stay and do the problems, you can, but, and then we'll either quiz Tuesday or Wednesday. I'll let you decide on Monday if you feel like you're ready for it on Tuesday or if we need to move it to Wednesday. All right, 34. So this one is similar to what we were doing earlier, where we're going to find velocity, speed, acceleration, and jerk, and then we're going to find all of those things at pi over 4. I don't know why they have these like so sporadic throughout this section, but anyways. So S equals the sine of t plus the cosine of t. So I'm just going to kind of set it up the same way I did the last one. So then the velocity function would be what?
Cosine t minus sine of t.
Yep. And I'm going to go ahead and evaluate over here at pi over 4. So v of pi over 4 is cosine of pi over 4 minus sine of pi over 4. So I have root 2 over 2 minus root 2 over 2. So that means that that's just equal to 0. Now for speed, obviously absolute value of v of t. So we can write the absolute value of cosine of t minus sine of t. But the absolute value of the velocity at pi over 4, obviously absolute value of 0 is still just 0, so nothing special about that one. Then equation for acceleration would be what?
Negative sine t minus cosine t.
Yep. So then acceleration at pi over 4, negative sine of pi over 4 minus the cosine of pi over 4. So negative root 2 over 2 minus root 2 over 2. So that ends up being negative 2 root 2 over 2. So that's just negative root 2. And then lastly is jerk. What would that one be?
Negative cosine t plus sine t.
Yep. So then j of pi over 4, negative cosine of pi over 4 plus sine of pi over 4. So again, we've got negative root 2 over 2 plus root 2 over 2. So that's also just 0. All right, so problems with this section. I feel like, oh, there they are. I was like, where are they? 1, 5, 9, 11, 13, 19, 21, 25, 29, and 33. And obviously, just like big thing is like just make sure you're memorizing those 6 trig functions. Usually on the quiz and the test, I'll like have you write them and then let me check them for you. It's not necessarily, it could be extra credit, but it's not necessarily extra credit. I kind of mix up what I do with that, but that way you'll know like before you're using them that you have them right, so that you're not just like getting all the problems wrong because you memorized them wrong. Because like obviously the ones other than sine and cosine you can verify like we did, but otherwise like that just takes a really long time. That's why I'm like, no, we don't have time for that.